In this video, I'll be going through a full course on how to build production AI agents in Python. We're going to write every single line of code, and I'm going to show you how to build 3 AI agents. The first is going to be a simple conversational agent that has access to conversational memory. The second is going to be a RAG-based agent where it can pull out information from like a company database. And then the last agent is going to be a multi-agent orchestrator where we actually have multiple AI agents running at the same time to achieve a longer running task. Now, this video is not designed for complete beginners, but as long as you're familiar with Python, you should be able to follow along. And we're going to be using a framework here called Agentspan, but don't worry, it is free, it is open source. You won't need to pay for anything. You just need to have access to some kind of AI model, so like OpenAI, Anthropic, whatever, but we'll go over that in a minute. Okay, now this is really going to be focused on how to build production AI agents. So rather than just agents that can run in your terminal or that run in a demo environment, ones that you could actually eventually scale up. Now, in order to do that, we need to talk about the main problems that you have when you actually try to run AI agents in production. Now, first, we have processes that crash mid-run, right? So maybe the network goes down, database freezes, whatever. Your AI agent just gets killed, and that means that a lot of the work that's done can be completely wasted, and that can be quite expensive over time. Next, human in the loop. So maybe we need a user to approve a task, something, right, or to press a button. That could take any amount of time. We're just unsure about that. Lastly, or not lastly, but thirdly, and one that's most important to me, is visibility. A lot of times when you build these AI agents, you have no idea what they're actually doing, so you need observability into the platform to see what step is on, where's it going wrong, what tools is it calling, etc. And then obviously scaling, a lot of times if you just build a simple like LangChain agent or something, it's not going to scale to tens of thousands of users, and you have to pretty much reinvent the wheel and spend most of your time deploying out all of this infrastructure when really you want to focus on just building the AI. So there's 7 things that you need if you want to have an AI agent actually be production ready, and I'm quickly going to go through them here. Now first, durability. That means that if the agent crashes, it can recover and it doesn't need to completely restart. Next, retries. So sometimes a step will fail. That doesn't mean we should completely exit the process. We should retry it multiple times. Human in the loop. Again, sometimes we need to delegate a task back to a human and say, hey, are you sure you want to do this? Do you want to issue the refund? Do you want to delete this file? XYZ, right? Observability. Like I talked about, we need to be able to actually see what's going on in real time. Long running tasks. If agents take 20, 32 hours to run, we should be able to handle that. And then scale and testing, which we can talk about a little bit later. Okay, so in order to accomplish what I just discussed there and essentially get these 7 features for our AI agents, we're going to be using a framework called Agentspan, which comes from Orchestration, who's kindly sponsored this video. Now don't worry, this is free. You don't need to pay for anything. It is completely open source. And I want to quickly just show you what it looks like when you actually get this running, because this is the benefit of using a platform like this. Now, Orchestration essentially gives us a server which is going to handle all of the different state and kind of track the progress of the multiple AI agents that we're running. So you can just see a few quick examples here from the dashboard. This is the server running on my own computer. You don't need to build this. You literally just install it and run it. And for any given AI agent, let's say we go to this analysis team agent, you can see a full log of everything that's actually gone on, and you can see this in real time. So in this case, we had a multi-agent system, and I can click into one of these agents and see the input, the output, the JSON, the summary, or actually go into the execution of this agent itself to see everything that went on. So this is the observability that I'm talking about. But what this also does is allow us to scale the agents by having a built-in queue system for all of them running. And then to retry tasks, for example, if we go here and we scroll down, you can see there was like 10 tasks that were running. And we can go through every single turn of the agent and see everything that went on along with the tokens, the reason it stopped, the duration, all of that good stuff. Now, this will make a lot more sense later, but effectively this is the backend infrastructure that we run our agents against. And each of these agents that you see here was me running code that connected to this server, and the server handled the state and the orchestration, but allowed all of the code to be executed where it was run. So from our local machine, from our server, whatever. But if there was a crash, for example, we could recover from that crash because all of the state is stored on this server. So we could just reconnect, restart where we left off, and it's not a big deal. And this task can run for as long as it needs to. So anyways, that's the basics on Agentspan. They also have their own Python framework for building AI agents, which we're going to use, but you also can connect them to LangGraph, the OpenAI SDK, Google ADK, I believe a few other ones as well, if you just want to use their orchestration layer or kind of the server that I talked about. Now, in terms of the kind of architecture here, let me quickly go through it. This is pretty much what it looks like. We have a worker. The worker is what we're going to write ourselves. We have the Agentspan server. This is already provided to us. Again, it's open source. We can run it ourselves. We don't need to pay for anything. And from here, this keeps track of all of the state, the history, allows us to retry, handle human in the loop, multi-agent, all of that kind of stuff. It's just handled for us. So from the worker side, we pretty much just say, hey, we're building an agent. We're going to connect to this server. All of the rest of the code stays exactly the same. The server handles all of that durable execution stuff that I talked about. And then, of course, we have an LLM. We can use any LLM that we want. So bring OpenAI, Claude, whatever. And that's essentially how it works. So anyways, that is the brief. That's what I'm going to show you how to do in this video. What I want to do now is hop over to the code editor. We're going to start getting some things installed and set up. And then from there, we're going to build out 3 unique AI agents, again, starting easy and then medium and more difficult. So you get a sense of how to actually build these. And again, how they work in production, which is the most important part, because at the end of this video, you could very easily go deploy this app by just deploying the server and deploying your workers, and you're good. That's it, because of the way that we built it, as opposed to if you use a lot of the other frameworks out there. Anyways, let's dive in. All right, so now we're going to get started with the installation steps here for Agentspan. Now I'm just on the documentation. I'll leave a link to it in the description. It's actually very good, so you can follow along. And a lot of the stuff that you see in this video, I just pulled directly from the documentation. Now, first things first, we need to install Agentspan and the Agentspan server. Once we have that installed, then it's very easy for us to just write the code, which is our worker code, which will connect to the server. Now notice that we can simply install it using pip install Agentspan. This of course requires that we have Python installed on our computer and that we have some kind of code editor. So in my case, I'm going to be using Cursor. You can use any editor that you want for this video. Now notice that what I've done in Cursor is I've just made a new folder here. So I just went File, and I went Open Folder, and I just selected one that was on my desktop, just made a new one called AI Agent Tutorial. From here, I've opened up the terminal, and I'm going to type uv-init dot. Let me zoom in a little bit so you guys can see this. And this is just going to make a new UV project because I'm going to use UV to install Agentspan. So you notice it says you can use UV pip install Agentspan. So from here, we're just going to type UV add Agentspan like so, and then it should add it to our environment for us and install everything that we need. Now you don't have to use UV, but I prefer to use UV, so that's what I'm going to do. Now I'm just going to delete this main.py file because we don't need that as well. So now if we go to the pyproject.toml, you can see Agentspan is installed. Okay, now the next thing that we need to do is set our LLM API key. Now the interesting thing about Agentspan is that it actually will hold the various provider keys for us. So any environment variable that you need to use, you don't have to have it in your worker code. You can have it stored on the server, which is going to be more secure. So I can actually put an OpenAI API key or Anthropic API key or whatever provider I want to use directly where I'm running my server, which you're going to see in a second. So what we're going to do is just get one of these API keys. For this video, I'm going to use OpenAI, but you can use Anthropic if you want. And what I'm doing is I'm going to platform.openai.com/home. Okay, this is going to let me make a new API key. You will need an account here and you will need to pay for this, but it is very cheap. We're talking about, maybe cents of spend to follow along with this tutorial. And I'm going to go create API key, and I'm just going to call this Agentspan and then maybe tutorial or something. Okay, now I'm going to make the key, and obviously you don't want to leak this to anyone, so I will delete it afterwards. Okay, so from here, we're going to go into our terminal, and we're going to type the command as it shows here from the documentation. So let's go back. Export OpenAI API key is equal to, and then the key. So we're going to say export OpenAI _API _key is equal to, and then we're going to paste the key inside of here. And then we're going to press enter. Now this should put it inside of the current shell session, which means that any command that we run after this should have access to this variable here, okay? So make sure that if you're gonna run the server again, that you first export the key beforehand. There's other ways to avoid doing that, but for now, this is the easiest, where you just have to have this environment variable set in your shell, okay, before you run it. Now, if you are on Windows, this command will likely look a little bit different. And if you're using something like Cursor, I would just ask it, hey, what is the equivalent command to, and then paste the export, OpenAI, whatever, for PowerShell, and it should tell you. I don't know what the exact command is, so I'm not going to guess, but you can just use an AI model and it should tell you how to export it properly. So now that it's exported, what we're going to attempt to do is run the Agentspan server. So we can just directly run the Agentspan server, or we can run Agentspan Doctor just to make sure that it's all working. Now, because I'm using UV, that means that if I want to run this, I need to do UV run and then Agentspan Doctor. If you're not and you just installed it globally with pip, you should be able to just run the Agentspan command. So from here, I'm going to press enter and let's see what it says. And it looks like all is good. It says, okay, OpenAI is set. Java is installed. We have enough disk space. The server jar is cached. That's because I've installed this previously. Now, if you didn't install this previously, it may tell you that something's wrong. And if that's the case, you may need to install, for example, Java 21, okay, etc. Now, if you don't know how to install it, again, ask the LLM. So ask something like Cursor, hey, how do I install Java 21? And it should give you the command. Okay, so now that that's running, we're going to type uv run agentspan server start. Okay, now this is the command to start the server. So we're going to go ahead and run that. And you can see that it says server is already running. Okay, let me stop the server because I may have it in another port. So to stop it, we're just going to go stop. Okay, and then I'm just going to restart it from here. So let's give it a second. And it says it's running on port 6767. We're just going to wait a minute and it says that it is running. So now if we want to test if the server is working, we can just copy this URL right here. We can go to our web browser and just paste it, and we should be able to see the Agentspan server. Okay, so from here, you'll see the Agentspan server. There's a bunch of stuff you can look through, but generally you're just gonna be looking through executions right here, and it's gonna show you a history of all of the executions. Now, obviously you won't see anything if it's your first time, but for me, I'm seeing previous executions because I've ran the server before. Okay, so we're gonna have a look at this later because it will make more sense when we actually get executions. But for now, let's go back to our project here, and let's start installing a few last things that we need, and then we can create our first AI agent. Okay, so I'm gonna right clear, and I'm just gonna type uv add. I'm gonna add a few dependencies that we need. Now, if you're not using uv, you can just use pip to add the equivalent dependencies. Now, first, we're just going to bring in python-.env, and we're also gonna bring in pydantic, and then lastly, firecrawl-py, which we're gonna use for the last agent. Okay, so go ahead and press on enter, and we should see that we get them all installed. Okay, so that's all we're gonna need installed for our project. What I'm gonna do now is just make a new folder, and I'm gonna call this agents. Now, inside of agents, I'm just gonna make a new agent, and I'm just gonna call this agent1.py, and this is where we're gonna start writing our code. Now, our first agent is just gonna be a simple conversational agent. All that means is that we're just gonna talk to it kind of like a chatbot, and the one thing that we're gonna add is that we're gonna allow the agent to know what our current time is and to get information about us as a user. We're also going to add memory so that anything that we say previously, it can actually remember. Because by default, if you don't add memory, I could say, hey, my name is Tim. It says, hey, Tim. And then the next conversation or the next time I ask it something, it will completely forget because it's not storing the previous responses. Okay, so that's the goal here. And this is just to show you the basics of the framework. And then we'll go into building some stuff that's more complicated. So we're going to start by importing logging. This is because there's a lot of logs that are going to be output by Agentspan, and we want to probably suppress some of them so we don't see too much in the terminal. We're then going to say from datetime, import datetime. We're then going to go from .env, import load.env, and we're just going to use load.env to load an environment variable file that we're going to need in a second. Next, we are going to say from Agentspan, and this is going to be .agents, make sure that you put plural. We're going to import agent, the agent runtime, okay, and runtime is with the lowercase there, and then conversation, memory, run, and tool. Okay, so this is all we're gonna need for now for this basic AI agent. Let me just close this so you guys can see it a little bit bigger. Okay, next lines, we're gonna load.env. What this is gonna do is load any environment variable files that are present. And in fact, while we're here, we're just gonna make a new .env file in the root of our project, so .env. And we are going to put inside of here one variable that we need. Now this variable is the agentspan underscore server underscore URL. Okay, and for now, this is going to be equal to http://localhost port 6767/API. Now let's make sure we spell this correct because I completely butchered the spelling here, but this is localhost, like so. Now, and let's add the extra slash. Okay, so this is where the Agentspan server is running right now. Again, we're running it on our own computer, so we just put in this URL, and yours will be the exact same. Now, if the Agentspan server was running on a different computer, it wasn't running on localhost, then of course we would change this, because maybe we're going to have the server hosted somewhere else and our workers hosted somewhere else. That's possible. You're also going to have the workers and the Agentspan server on the same server. It's completely up to how you want to deploy it. But this is what allows you to specify, hey, where actually is this server? Okay, so next we're gonna go back to agent 1. We've now loaded the .env, and because we've loaded that, Agentspan will now automatically see this variable, and it will know that it needs to communicate with the server at that location. Now next, what we're gonna do is just say logging.basic config, and we're just gonna set the level. So we're gonna say level is equal to logging.warning. Okay, just so we only show warnings and we don't show all of the logs that are probably going to kind of mess up the terminal. We're then going to say logging.getLogger, and we're going to get the Agentspan logger. So let's get it like that. And we're going to set the level to warning as well. And then nextly, we're going to put not Agentspan, but we're going to put conductor. And same thing, we're going to set the level to warning just so that we don't accidentally get a bunch of random info logs showing up. All right, so next what we're going to do is we're going to create a basic agent. So to make an agent is super easy. We're just going to say assistant is equal to agent, and then inside of here we're just going to give the agent a name, and this is what's going to show up in Agentspan so we can see it. So we're going to call this personal assistant like that. Perfect. Next we need to specify the model. Now because we're using OpenAI, we can specify any OpenAI model and we'll be able to connect to it and use it because we have that API key set. If we wanted to use an Anthropic model, then when we started running the Agentspan server, we would have needed to declare an Anthropic API key or a Gemini API key or whatever the other model is that you want to use, right? If we go back here, you can see that we had the option, right? We could have exported one of these. So based on the one that we export, and you can see all the providers here, right? It gives you the different options. You can specify the model that you want to use, okay? So we're going to go back here and we're going to change this to OpenAI/GPT-5.4. This is a little bit expensive. If you just want a cheaper one, you can do GPT-4o or GPT-4o mini, and that's going to give you a really cheap model that's going to cost literally nothing. This one still will not be expensive based on how we're using it, but it is more expensive. Next, we're going to pass some instructions. Now, the instructions I'm going to put in a set of braces just so that I can separate them out with some quotation marks here, and this is the system prompt. This is what's going to be read at the beginning of each message so that it understands how it should actually behave. So we could say something like, you are a concise personal assistant, use tools when they help, because we're going to provide some tools to this in a second. And then down here, we're going to say, and remember useful, okay, user details across turns. Okay, cool. So that's our instructions. Now beneath this, we're going to provide some tools. For now, the tool list is going to be empty. And then after this, we are going to provide some memory, but we'll just add those later. So for now, we just have the basic agent. Next thing we're going to do is just run the agent. So to run the agent, we're going to say if __name __ equals __ main __. This is just the main entry point in our application. If you're unfamiliar with what this does, essentially it just checks to make sure we're running this Python file directly. We're just going to do a print statement, and we're going to say starting agent ... Okay, and then down here we're going to say with the agent runtime, okay, as runtime. And then we're just going to go into a simple while loop where we just keep asking the agent questions until we type quit. Okay, so we have our with. This is how you start the runtime for the agent. We're now going to say while true. And then here we're going to say prompt is equal to input, and that's going to be u.strip, just to remove any leading or trailing spaces. We're going to say if the prompt.lower, okay, is equal to q. So if you type the letter q, then we're just going to break. Okay, and we're going to say if not prompt, then we're going to continue and just ask you to type something so that if you don't type anything at all, we don't prompt the model. Okay, now down here, but still inside of the while loop, we are going to do the following. We're going to say the results is equal to run, and we're going to run the assistant. We're going to pass our prompt, and we're going to say the runtime is equal to the agent runtime right here. And that's it. That's all we need to do to run the agent. So for now, what we can do is we can just say print, and we can put an F string, and we can say assistant like this, and then we can just put inside of a set of braces, maybe what is this? Result, okay? Now this is going to give us kind of a messy dictionary, which we can look through later, but at least for right now, it should give us the response. So let me zoom out a little bit so you guys can read this better. Essentially what we've done is we've imported a few things that we need. We've set up the env so we can connect to the server. We have the assistant. We don't have any tools or anything. It's just a super basic assistant. And we set up a while loop so we can now communicate with it. And if we go here, we'll just make sure the Agentspan server is running. I believe I didn't shut it down, so it should still be running here. Yes, looks like it is. So make sure that the Agentspan server is going, guys, before you try to do this. And then what we can do is from the root of our directory, we're going to type uv run and then agents/agent1.py. Now notice that I'm doing this from where my env file is present, so I'm doing kind of the path to this file, agent/agent1.py, so that we're going to pick up the env file and we're going to load it, and let's hit enter. Now it says starting agent. You can see we've initialized, we've connected to the server, and now we can type something like hello world, and we give it a second here. Okay, and let's see if we get the response. And it says, hey, it was completed, and then we get this agent result here where we have some result in the output called hello world. So we can see everything ran, and then if we come back here, let's just refresh the server. You see personal assistant just ran, and if we click into this, you can see our prompt, which was, where is it here? Hello world. We can see the output of the model was hello world. Okay, that's right from the LLM, and then we can see the immediate output at the end here was this, right? What we got with hello world. Cool. So that's kind of the benefit, is that we can see exactly what's going on. We have full insight into how the AI agent is running. And of course, this is just a very basic one. Now what I'm going to do is just type Q to get out of this, and let's make it so that we can kind of view the response a little bit better. So rather than just printing out the result object here, let's print out the kind of output here. So what I'm going to do is say, so I'm just going to say result.get, and then I think we can just put in single quotes here, result, make sure that it's single quotes, otherwise it's going to interfere with the F string. And let's just try this one more time where we run the agent. So let's go UV run, let's go hello, and let's see what we get this time. It says agent result has no attribute get. Okay, interesting. So I think we can do result.output.get maybe. I think that's going to work. Let's just try it. I'm just doing this off the top of my head here, and let's run it again and just type hello. And let's see now if we get the correct response. Give it a second, and there we go. We get hello, how can I help you? And I say, what is my name or something, whatever, and it's not going to know the answer, but the point is that this is now functioning. I don't know your name. If you want to tell me, I'll remember it for later. Okay, cool. All right, so this is great. However, like I mentioned, we currently don't have any tools or any memory. So anything that I chat with the AI agent is not going to remember later on, even though it said that it would. So what I want to do now is I want to start by adding a few tools. These are things that the agent will be able to actually call to get some information, and then we're going to add memory. So to add a tool is super simple. What we can do is we can just make a function. So we can say something like define get current time, and then what we're going to do is just return whatever the current time is. Now it's important that when we write these tools, we also write doc strings for them and the input and output format, so that Agentspan can automatically convert that into something that the AI agent can read. So for example, I'm going to say, okay, the get current time function is going to return a string. And if it was going to take some input here, then I would also specify like, input and then whatever type the input was. And then beneath this, importantly, I'm going to write a doc string, which is just a comment at the top of the function that says returns the current local time. Okay, and then you can see that we have datetime.now, and then we just convert this into a string and we return that. Now this is great, but if I want to turn this into a tool, I simply just have to put @tool. Now what is a tool? A tool is something that an AI agent can call to get some kind of response or to take some kind of action. So right now the AI agent doesn't know anything about us. It can't actually do anything. It's just capable of essentially, printing out text, right? Or giving us a text response. If we want it to actually take an action and generate a report or search for something, it needs to have tools in order to use that. Now, Agentspan natively defines the ability to call tools, so all we have to do is just define a function. We specify it's a tool using this @tool decorator, right, like we specified here. Then the name of the tool will automatically be the name of the function, so make sure you name the function something useful. The input and output type you'll specify, and then the description of the tool you'll put as the doc string. So what will happen is Agentspan will now say, hey, we have a tool, get current time, right? The description of this is whatever the description was here, and it takes no input and gives this output. And then that will be passed to the assistant, and the assistant will essentially give us a response back that says, hey, I want to call this tool. And then inside of this runtime here, Agentspan will automatically call the tool for us and then give the response back to the model. And we'll be able to see this happening inside of the UI, which I'll show you in a second. So for now, we can just pass this get current time tool, and the model, if we run it again, should be able to call this if we ask it about something related to the time. So that's not what I meant to do. Let me open up the terminal and run this again. I'm going to say, what time is it? Okay, and let's see if we get the time here. Give this a second, and hopefully it's going to call that and then tell us what it is. Okay, and you can see it says that it's this time, and if I look at my window here, that is the correct time. Okay, 1947 and 2 seconds. Boom. Now if we go back to the server and we refresh, we can check our personal assistant, and we can see now that actually it called a tool. So the LLM gave some output. The output effectively said, hey, I want to call a tool. The name of that tool is getCurrentTime. Okay, so then we called the tool. We got the input, which was this. We got the output, which was the result. Right, and then we passed it to the model. Now the model now has access to that tool call, so it knows what the time was, right, and then it gives us the output. Boom, here's the time. So that's one of the reasons why this is super useful, is that you get that full insight into what the AI model is actually doing. Now let me say, what time was it last time I asked you? Just to show you something. And you should see here that assuming it doesn't just call it, yeah, it says, I don't have access to timestamps or your previous messages in the chat unless they're shown in the inference. So essentially what it's telling us is that, hey, I don't know what it was because I don't have memory. So the next step here is to add memory to the agent. Now adding memory is super easy. All we have to do here is just go above our agent, and we're gonna say conversation underscore memory is equal to conversation memory like so. Then inside of here, we can also put the maximum number of messages that we want to store. So I can say max messages is equal to like 50 or something. So after 50, it will start just getting rid of the last messages so we don't clog up the context too much. And then what I can do is just say memory is equal to conversation memory. Boom. So that's that. So what we can do now is, let's open this up. Let's type clear. Okay, and let's go UV run, and let's do something. My name is Tim. Okay, and let's see if you can remember that. Okay, so it says, nice to meet you. I'm gonna say, what is my name? And let's see if I can remember this now using the conversation memory. Okay, and it doesn't remember it because I made one mistake and I forgot to add to the conversation memory. So let's do that now. That's actually a good issue to run into. Okay, so we've created the conversation memory. We've added it to the agent, but we're not adding anything to the memory yet. So what we need to do is we need to add what we type and what the agent types to the memory. So the way we do this is we're just going to go here and let's go underneath the result. And we're going to say conversation memory dot add underscore user underscore message. And this is going to be the message that we sent, which is the prompt. We're then going to say conversation memory dot, and this is going to be add assistant message. And we're going to add the result dot output dot get and then the result. And just to make this a little bit cleaner, we're going to say readable result is equal to this. And then we can just replace this with the readable result, and then same thing here with the readable result. Okay, so essentially what we're doing is saying, hey, we're going to append to the memory. The memory has a few different functions we can call. One is to add a user message, which is what we said, and then one is to add an assistant message, which is what they said. So let's save this, and now let's go again to our terminal. Let's make sure I didn't mess something up. I think it's okay. Let's clear. Okay, so let's run it again, and let's see what we get this time. I'm going to say, my name is Tim. Okay, and let's see here, give it a second, say, what is my name? And hopefully it's going to give us the answer and tell us that it's Tim. Let's see. I don't know your name yet. Okay, what? I'm going to say, my name is Tim. Let's try it one more time. I think sometimes on the first run, for some reason, it's not picking it up based on kind of how we're adding this maybe. Let's see. Okay, what is my name? And let's see now. There we go. Your name is Tim. Okay, so for some reason on the first run, I think based on how I added the info here, it's not working. I'm not sure exactly why that was the case, but either way, afterwards, now it looks like it's working and it is able to determine my name. It also may just be how it's searching through the memory. Either way, looks like we are good and it knows my name now. Okay, so anyways, the memory is functioning. Now that we have that, let's move on to our next agent, which is going to be a RAG-based agent. Okay, so as discussed, we're now moving on to Agent 2. Agent 2 is going to be kind of a RAG-based agent where we're going to be able to look up some info in something like a database or documentation or whatever we have. I'm not going to build true RAG here because that's going to be a little bit complicated, but of course you could very easily add that. Effectively, what we're going to do is add some more tools. We're going to add guardrails, and we're just going to look at a much more complex agent that has a few more components to it. Now we're also going to look at a pydantic structured output agent. Now what that means is that rather than just getting the output as kind of a random string of text, we can actually pipe it into a Python object so that it's predictable and we know what kind of format we're going to have. So as you can see here, I've already brought in a bit of code. Any of this code will be available from the link in the description. If you just want to copy it, there'll be a GitHub repo there. But I just wanted to save us a bit of time, so I just did the imports. You can see we've got a bunch of stuff from Agentspan here, and then we have the mock database documentation, and then the logging setup, as well as the loading.env. Okay, so if we go down here, the first thing that I'm going to do is I'm actually going to define what I'm going to call the Pydantic structured output object. Now, this is how I want the agent to give us its output. So rather than just giving me some random text that maybe I have to parse through, I want it to give me something in kind of a dictionary format that I can then convert into a Python object so I can read the different values. Now, you're going to see what I mean, but I'm just going to go class support response like this. And then this is going to inherit from base model, if I can type it correctly, which we brought in here from Pydantic, okay? Now, Pydantic allows us to just do typing in Python, and it's used with a lot of these AI frameworks. So first things first, I'm going to say that I want this AI model to actually give me output that has the following fields. The first is a stage. So I'm going to say stage string is equal to a field, and then I can actually just give a description for this field, and I'm going to say stage like answered. Okay, so answered, refunded, or rejected, because this is going to be related to kind of the support request, because we're setting up kind of like a support agent here that has the ability to do this rack. Next, we're going to have successful Boolean, and this is just going to be a Boolean, so we know if it's successful or not, and then we're going to have a message, which is a string. Now, this is a super basic structured response, but if we wanted it to give us like a price or a number or a time or something specific, then we just set that as a field, and the model will automatically fill in these values. So now it's going to give us always a stage, which will fit this description, and it will give us whether it was successful and what the message was. And then if we had other types, we could set those here. We could set up enums. We can do anything you want. I'm just trying to show you that you do have this ability to use structured output, which is really powerful for more deterministic AI applications. Okay, now before we build the model, or before we build the agent, I want to set up a few tools. So the first tool is going to be one that can search our knowledge base. So I'm going to say define search knowledge underscore base, and we're going to take in a query, which is a string, and we're going to have a string, which is a response. Now, for the description of this tool, let's put it in here. We're going to say search support docs, like this, okay? Pretty basic. We're just saying, hey, this can sort through our support documentation. Let's fix the comment. And what we're going to do is the following. We're going to say for title, and then body in docs dot items. We're going to say if the title is in query dot lower, then what we're going to do is just return the body. This is not an efficient search by any means, but all we're effectively doing is just a quick keyword search. So if any keyword of what the user typed in was in this, so like shipping, refund policy, account, whatever, then we're just going to return whatever the body or the content of this is. Again, if you use RealRag, you can get a much better response, but I'm just showing you how you can set this up. So next we're going to say return no matching support articles found. Okay, so if there's not a response. So that's the first tool we're going to have. Next, we're going to have some tools related to looking up some orders. Okay, so we're going to have a tool. This is going to be define lookup underscore order. So let's do this. For the order, we're going to have an order ID, which is a string, and this is going to return a dictionary with the information about the order. Now, same thing, we're going to have the comment lookup order in database, pretty basic, and we're going to say by ID. And then what we're going to do is return the mock underscore DB, and then the orders like this. And then we're going to say .get, and then this is going to be the order ID. And if the order ID is not found, then we're going to return a dictionary, and the dictionary is just going to say error, order not found. Okay, so that's going to be our lookup order tool, and then we are going to have a few other tools as well. We'll look at those later. So we're going to have one tool that will allow the user to refund. However, before we call that tool, we are going to ask for a human in the loop approval, because we don't want to just automatically refund something unless the user actually allows that. Okay, so for now, let's create the support agent. Let's run it with the two tools so far just to make sure that these work, and then we'll move on to the rest. So we're going to say support agent is equal to agent. For the agent, we're going to say the name is support agent. For the model, we're going to go with OpenAI / GPT 5-4. Then we're going to have some instructions. I'm just going to copy these in because they're kind of long, and you guys can adjust them, but you'll see kind of how I've written them here. So we're going to say instructions, and then I'm just going to copy in this long paragraph. So give me 1 second, which looks like this. So that you are a customer support agent. Use the knowledge base first. If the customer wants a refund, when you know the order ID, call the lookup order to get the amount. Before calling process refund, write a short plain English sentence describing exactly what's a refund you're about to issue, etc. Okay, so this is the instructions. Next, we're going to specify the output type. So this is a new one. And we're going to say output type is the support response. Now, what this allows us to do is specify any Pydantic object, so like one that we have right here, and that's now going to force the model to give us the output in this format. So that's all we need to do. We just say, hey, we want it in this format. Now it's going to give it to us in that object, which you're going to see in a second. Now, next, we're going to specify the tools. So the tools are just going to be the search knowledge base and then the lookup order. We will have conversational memory, so we'll keep that for right now. And then we can specify max_turns is equal to 10. Now, what this will do is just specify the number of times that we can go back and forth with the AI agent until we reset the session. Now, for the conversation memory here, we can actually just specify it like this. And when we do that, it should automatically add all of the contents to conversation memory for us. Now, the reason I didn't do it here is just because I wanted to show you that you can manually control the memory, but by default, it will automatically add everything, including the tool calls to memory when you, oops, that's not what I wanted, specify it like this. Okay, so actually if I go to the docs, you can see that you can manually add it as it shows here. And then there's 5 methods or 6 methods like user message, system message, tool call, tool result. So if you don't manually add it like we did, then it will just add all of these for you automatically, which is good, obviously, right? But sometimes you want to just add certain pieces so then you can control it yourself as we did in example 1. Okay, but for now we have our memory and we have our agent. So now we need to be able to run the agent. So what I'm going to do is create a function. This is going to be called run interactive. Okay, for this, let's spell interactive correctly. We're going to take in a prompt, which is a string, and we're just going to return nothing or none. Okay, from here, we're going to say with the agent runtime, just like last time, as runtime. What we're going to do is we're going to say handle is equal to start. This is a different function. We're not running the agent. And this is going to be support agent, prompt, and then runtime is equal to runtime. Now, the reason we're doing this is that we want to have a little bit more control this time, and we want to actually be able to hook into what the agent is doing to see, for example, if it needs approval from us, if there's a guardrail that ran, which we're going to look at in a second. And this gives us just a little bit more control in terms of what the agent's doing. So it will allow us to actually stop approval request, as you're going to see. So what we're going to do now is we're going to say stream is equal to handle.stream. And before I go any further, let me just refer to the docs so you can kind of get a sense of how this works. So if we go to the streaming page here, I'm doing it a little bit differently than it shows in the docs, but you can see that we can actually hook into the stream of the agent, which allows us to see all of the events that are happening. So we can see, for example, if it's thinking, if it's calling a tool, if there's a result, if there's a handoff, and if it's waiting. So if it's waiting, what that means is that it's waiting for us to approve something which we need to manually do. So this allows us to have some more control into what the agent's doing rather than just purely getting the result. We can see all of the steps in the meantime. So I'm going to show you how I'm going to do it here. Again, you can reference the docs and you can do it a little bit differently. So we're going to say order_ID, amount is equal to none and none, because I want to potentially know if the user wants to refund an order, which we're going to have a look at in a second. And then what we're going to do is we're going to say for event in stream. For now, I'm just going to pass. But this will allow us to actually view all of the stuff that's going on before eventually we get a result. Now we'll handle that in a second, but for now what I'm going to do is just go down here and say result is equal to stream.get_result. This will then give us the result once all of these events are finished and we've gone through them. And we're going to say output is equal to result.output. Okay? Then we can actually just tack on message here. The reason for that is that we know that it should be in this support response object type. So we get result.output, and then the output is going to be this. We know that there's going to be a message, so we can simply just view that. Okay. Then what we need to do is just print out the message. So we're just going to say print, and we can put an F string, and we can put a new line character here. And I'm just going to put let's put output, and then \n. Okay, so we'll start running this in 1 second. In order to do that, we're just going to do if underscore underscore name underscore underscore is equal to underscore underscore main underscore underscore. Then what we can do is say print, and we can print support bot starting dot dot dot. Then we can go down here and we can just do a simple while loop. It actually knows exactly what I want. Okay, so we're going to say while true, the prompt is you. If you enter Q, then break. If there's not a prompt, then just continue. And then otherwise, just simply run interactive, which is this function that we wrote to run the agent. Now, like I said, there's some more stuff that we're going to add. But for now, let's just see if it can look up the order or look through the knowledge base before we go any further. Okay, so let's simply open this up. And let's go uv run agents/agent2.py. And we got an issue here. Instructions. I think I just spelled instructions incorrectly, so let's just fix that. Instructions like so. Okay, let's run it again. And it says you. I'm going to say, can you tell me about shipping? And let's see if it can look that up and if we get the result. Okay, and it says dictionary object has no attribute message. Interesting. Let's have a look at why we're getting that. It's got to be something to do with this. So for now, let's just print whatever this result is. Let's see what it is, and then we can parse through it. So let's say shipping or something. And let's see if it finds anything, and it gives us, okay, agent result output error failed with status failed and reason model GPT 5.4 does not exist. Okay, so that's good. We found the issue there. So OpenAI/GPT. And I think this is -5.4. Let's look at what we had in the first agent. Yeah, -5.4. Okay, silly error, but at least it gives us the response there. And now we can just quit this, rerun, and let's see shipping. And let's see what we get if it works this time. Okay, so I'm just playing around with this just to get the correct output. And we can see that the way we can do that is by doing result.output.get and then result. Now that will then give us the format as specified here. However, it doesn't give it to us in the Python object. It gives it to us in a dictionary that is the same format as this, which is still effectively the exact same thing. So you can see we get stage, completed, successful, true, message, standard shipping takes 3 to 7 business days when I type shipping. Now let's ask it, can you look up my order? And let's see if that will work. What's the order ID? A100, so let's type that in. Stage, need order ID, successful, false, message, sure, please send me your ID. So we're gonna say A100, and so let's see if it can look that up now. Give it a second here to give us that response. Okay, come on, I hope it's calling the tool. Being a little bit slow, and it says refund pending info. Okay, message, I can help with the refund, but I need your request to proceed. Your order A100 was found for $49.99. If you want a refund for this order, please confirm and I'll continue. Okay, cool. So it looked it up, we get the information, and now if we go back to the Agentspan server here and we refresh, we can see, first of all, these ones failed, and we can actually see all of the logs on why this failed, which is interesting, as well as the debug view here on exactly what went wrong. Anyways, let's go back to the most recent one though. We can see we have this support agent. We have multiple turns, so we can see how those worked. So you can see we typed in A100 and then it looked up the order. This was the input. This was the output. It got us the information, and then it gave us that full JSON for the tool call, went to the LLM, and then gave us the output. Now you'll notice that this is just one run. If we go back, right, you can see this was the other run. Can you look up my order? Boom, and then it's remembering all of this based on the conversation memory. Okay, cool, so that's functioning. Now let's move on to add a few other things to our agent. So one thing that I want to add now is the ability to refund. But like I said, we shouldn't just refund unless we get approval from the human to do that. So in order to do this, we can just make another tool. This can be add tool, but this time we are going to say approval underscore required is equal to true. Now this means that we need to manually approve this in order for the function to execute. I'm going to show you how we do that. Now for the function, we're going to go process refund. We're going to take in an order ID, and we're going to take in an amount that we want to be refunded, and then we're going to return not a Boolean, but a string. Okay, now we need to give a description. So for the description, we're going to say, let's go like this, request a refund. Okay, refund, pause for human approval, think before you run this. Okay. Cool, just so it knows that this should be a careful operation. Then we're just going to return even though we're not really going to do anything here. We're just going to say refunded, and we'll put inside of brackets amount colon dot 2f, okay, for order ID. We're kind of faking a refund, but I'm just showing you that we can build a tool that requires the human approval, which is kind of the more important part. So now that we have that tool, we're just going to add that to our tool list. So we're going to say process refund. Now the thing is, we need to start handling this stream here in order to actually process that refund. So what I can do is the following now. I can say if event.type is equal to, and then this is event_type.tool, okay, tool underscore call like so, and event.args, meaning it has some arguments. I'm going to say my order ID is equal to event.args.get order ID, or like this, or order underscore ID, or order underscore ID. Now what I'm effectively saying is, hey, I'm going to try to look through these tool calls to see if we ever call an order ID when we're looking up something or calling one of these tools, because that's then the order ID we'll be referencing when we're trying to refund something, okay? So I'm just pulling out that order ID. Otherwise, I'm going to say if event.type is equal to event_type.tool underscore result, okay, and is instance event.result a dictionary, then what I'm going to do here is say amount is equal to event.result.get, and I'm going to get a total or an amount. So same thing, now I'm going to look in the tool result to see if I can figure out what the amount is that we're refunding for the order. It's kind of a weird way to do it, but it allows me to parse through and see tool calls, tool result. And then lastly, I'm going to say elif the event.type is equal to event_type.waiting. Then what I'm going to do is I'm going to print the following, okay? And this message is going to be essentially saying, hey, we're requesting to refund, and then I'm pulling out the two arguments that I have, so order ID and amount, so I can print those and then tell them, hey, do you want to approve this? And if they do, then we can approve it. So here's how it works. I'm just going to say print, and this is going to be an F string. I'm going to go /n, and I'm going to go approval required, and then I'm going to say refund, and we're just going to put the order, actually, let's put the amount. So we'll put a $, like this, amount, and then :2f for order, and then the order ID, okay? And then down here, we're just gonna put a print, and we're gonna say, press enter to approve. Technically, you can't actually press anything else, and this is gonna be an input statement, not this, so we're not even gonna check what it is, and then we're just gonna say handle.approve. Okay, so effectively when we call handle.approve, we're just going to approve that operation. So it's just going to wait for the human to be at this step. And then as soon as we want to approve, boom, we go ahead and run approve, and we're good to go. Okay, so now that we have that, we're going to ask them to approve it. So I'm going to say decision is equal to input, and we're just going to ask them approve, yes or no, and then lower.strip. We're going to say if the decision is Y, then let me just check the documentation here. It is handle.approve. Okay, so we're just going to say handle.approve like so. Okay, otherwise we can say handle dot, and I believe it is reject. Let's see. Yes, you can reject, and you can pass a reason if you want to pass a reason. Just say user rejected. Okay, cool. So that is how we can now handle this. Again, the reason why I'm looking at these tool calls is just so I can figure out the kind of amount that we're going to have for the refund, because otherwise it's not going to tell us that beforehand. So anyways, now let us go and run this and see if this works with the refund. Okay, so we're going to clear, and then we're going to go UV run agents2. I'm going to say I want to refund an order. And it gave us an issue saying tool result just because I didn't have a capital L here. So let's fix that. And now we're good. And rerun. And let's say refund an order. Okay, and let's see what we get. And it says that it needs an ID, so it says I can help that. Please give me the order ID so I can look it up. Okay, so let's go A100 and see. Okay, and it says approval is required, refund $49.90 for order A100. So you can see these steps here picked up that information for us because it saw that we were doing a tool call to either attempt to refund or to look up the order ID. So it picked those up, saved them in the variable, and then we're using them in this step to tell them, hey, we now want to call this because we're waiting for your approval. The only thing we could be waiting for approval for is this function, right? Because that's the only one that we have. So I'm just going to go ahead and type on yes to approve this. And then hopefully it's going to tell us that it was able to refund it. Let's see. It says stage completed, message sure, your refund was issued successfully. Boom. Now let's say refund order again. Okay, and hopefully it's going to give us maybe another ID. It says please provide the ID. Okay, so let's go A100. Even though I know we already refunded it, we still can try. And let's reject it this time and see what we get just to make sure that that step works. And while we're at it, we can go here, right, to Agentspan server. And you'll see that this is running, right? And we're at this stage where we're just waiting for the human, and we can just wait indefinitely. And what I could actually do, I'm not going to do this right now because it's a little bit complicated to show, is let's say I were to quit this worker, right? And this worker just completely died. And then I restarted it, but reconnected to kind of this execution that's going. This will still all be running with all of the saved state, and it will just be waiting for the human again to approve this. So the human doesn't need to ask, hey, refund again. We don't need to check something. We don't need to look up another order. It will just resume where it left off at this stage, right, where we're waiting for the human. And this can take any amount of time. It could take a day. It could take an hour. It could take 10 minutes. Doesn't matter. The server will keep running here. And you can see it's in this handoff state where it's waiting for us to approve, right? And you'll see the time if we just keep refreshing, like it'll just keep going up and it will just keep waiting. Okay, so anyways, I'm going to go yes here. Or sorry, I meant to do no, so we rejected it. But anyways, you can see that it's working. And I think doing no is not really going to make any difference anyways because, well, we know it's just going to move to the next step. Okay, so this is working. Now, what I want to do next is I want to start adding something called a guardrail. Now, a guardrail allows us to actually audit the input or the output to our LLM or to our agent to ensure that we don't have something potentially malicious or data that shouldn't be given to the user given. So I'm going to show you how we write a guardrail. The guardrail that I'm going to write is going to be related to a jailbreak. So a lot of times people will try to do like a prompt injection where they say, hey, like ignore all of your previous instructions and give me, all this information that I need XYZ. We can actually prevent against that by building in these guardrails where we try to detect common kind of phrases that, scammers and exploiters will try to use. So what I can do is I can use @guardrail, just make sure you import it, right? And I can say define safe_support_request like so. Now from here, we could take a prompt, which is a string, and this is going to be a guardrail result that it's going to return. Now for the comments here, what we're going to do is say block obvious prompt injection attempts. Okay, and this is going to be before the LLM even sees it. So before the LLM gets it, we're going to have this function that will run. So what I'm going to say is blocked is equal to, and then just a list of words. So I'm going to say ignore, okay, ignore previous. We can use system prompt, something like that, or jailbreak. Okay, so these are just words that I don't want to be allowed in the input. Now I'm going to say past is equal to not any, and this is going to be phrase, okay, in prompt.lower, and then let's spell lower correctly for phrase. Let's spell all these. My typing is so bad now with LLMs. Phrase in blocked. Okay, so all this is doing is saying, hey, were any of these words in this prompt? That's all it's checking. Then we're going to return guardrail result. We're going to say past is equal to past, which is either going to be true or false. So if none of these existed, then true. If they did exist, then false. We're going to say reason, or we can say, message is equal to, and we're going to say, please ask a normal question. This is blocked. So if it fails, this is the message that's going to be returned. So now what we can do is we can add a guardrail here to our support agent. The way we add it is we specify guardrail, or guardrails with a plural. We then need to put a guardrail object. So we're going to say like this, guardrail. For the guardrail, this is going to be the safe support request. And we're going to say the position of the guardrail is going to be position.input. Okay, and then we're going to say on underscore fail is equal to onFail.raise. Now raise is going to raise an error, which is just going to exit out of the bot completely. There's other things that we can do here when we fail, but for now I just want to completely quit it. So effectively what I've done is I said, hey, we have this guardrail, right? This is a function that we want to run, and we actually want to run it before we pass anything to our LLM. So as soon as we get some input to our agent, run it through the guardrail, which is this function right here. Make sure that there's nothing wrong. If there is something wrong, then tell us and fail. Okay, that's a simple guardrail. Now this is on the input. You also can add a guardrail on the output, which I'm going to show you from the docs here. So if we go to guardrails here, you can see there's a bunch of stuff that we brought in here. You can see guardrail, we have a word limit. So for example, we're checking to make sure that, what do you call it here? We're going to have a correct number of characters. And you can see for the failure modes here that you have like retry, raise, fix, human, etc. Okay. In terms of constructing the guardrail, you can do the function position, right? So output, input on fail, the name, and then the maximum number of retries that you want. And for position, do either input or output. So either run after or run before. Now there's a bunch of guardrails you can do here. You can do a custom one like the one that we just did. You can do a regular expression guardrail if you want to just check for certain characters like we were kind of doing. I just don't like to write regex, sorry, because it's a little bit complicated. And you can do an LLM guardrail. So if you do an LLM guardrail, you're actually using an LLM to then either get the, fail or pass. The issue with this is that you still can have prompt injection going to then this LLM that's doing the guardrail. But the point is you can use an LLM to actually detect, hey, is this good? Is this bad? Whatever, okay? And then same thing, input guardrails as we saw here, auto fix. There's a bunch of different ones that you can set up as you can see like this, okay? So I'm not gonna go through all of them. But just wanted to show you that these are super interesting, very good to add to the agent. So now that we've added this, let's try it. And let's just go clear and run. So we forgot to pass a comma. Maybe, let me see where that is. Yes, we forgot the comma here. So let's add that and rerun. And I'm going to say, jailbreak this prompt. Okay, and you can see, boom, it just immediately crashes and gives us the error, input guardrail safe, support request failed. Please ask a normal question. This is blocked. Okay, so we ran into the guardrail, and then of course if we run this and we say, help me or something, we won't run into the guardrail because, well, it was not triggered. Okay, give this a second. Hopefully it will give us the response. Not sure why this one's taking so long, maybe we're getting rate limited or something. Okay, and you can see that it gives us the response here, and also you'll notice that there's no run for this guardrailed execution because we never even got to the LLM. It just immediately blocked it before it even passed it to the server. So like as I was scrolling through here, I actually couldn't find one that was that execution. Yeah, see, it's actually not showing up here at all. Just help me, yeah. Because we never even hit the server because we immediately exited after the guardrail. Okay, so again, a lot of other stuff you can do with the guardrail there. Not gonna go through all of it, but with that said, that is gonna wrap up our second agent. This was a little bit complicated. We added a lot of stuff. We had tools, output type, memory, guardrails, what else? Human in the loop approvals, kind of getting into the stream of what's actually going on with the AI agent. And again, all of this is available from the documentation. We have streaming, as you can see here. We have testing, which we're gonna look at later. We have the memory, right? Adding conversation memory. We have tools, right? So check all of this and you'll be able to see how it works. And you can also add HTTP tools, API tools, and MCP tools as well if you don't want to add custom function ones like the ones that we've written so far. Anyways, now let's move on to agent 3, which is going to be a multi-agent kind of orchestration agent where there's multiple agents that can be triggered at once to perform a long-running task. All right, so we finished the first two agents where we're actually writing all of the code manually. Now we're gonna move on to agent 3, which is gonna be going over multi-agent strategies. Now what we're gonna be building is a multi-agent researcher. So it's actually gonna be very similar to what we have in the docs here. So I'm not gonna write every line of code from scratch. I'm just gonna run you through it at a high level because this code will be available from the link in the description. And I'm gonna explain the different strategies that you can use and show the executions. So this is the code that I have. I'm just going to quickly skim through it, and then I'm going to explain how you can configure this to be useful for whatever example you're trying to build. Okay, so effectively what I have here is a bunch of different agents. I have a researcher agent. I have a writer agent, I have an editor agent, I have a market analyst, a risk analyst, financial analyst, an analyst team or analysis team, and then I have these different agent pipelines, which we're gonna have a look at in a second. And then I have just a few things that will kind of create and save a report manually for us, because that's how I'm gonna kind of set it up. But effectively, the way this agent is going to work, I'll run a few in a second, is that I'm going to tell it, hey, I want to do research on Tech with Tim, for example. And the strategy I want to use for the research is sequential, which means, run these in individual steps. And then what will happen is it will go and use all of these different agents, gather information, and generate a research report for me. That's what this agent is. Again, I'm going to show you how it works, and we'll run through the code in a second. Now, the way that I'm able to do this is because Agentspan supports these multi-agent strategies. Now, here's the following strategies. First is handoff. Okay, LLM chooses which sub-agent to handle the request. This you can write similar to this, if I can find it right here, where essentially you just write an agent, you give it access to some other agents. These agents can be exactly what we just built before, and then you change the strategy here to say handoff. That's it. And then you just trigger this agent the way that we've been running them, and it will just go and, let's remove this, be able to use each agent as it needs to use them, as you chat with it. So it has all these different agents beneath it, similar to if you're using like Claude Code and you have sub-agents set up. Okay, then you have sequential. Straightforward, this just means that we always run the agents in a, kind of linear path. So we run them one by one, and then we take the result of one agent and we pass it to the other. And you can see sequential looks like this, right? We run, we get the result, we pass the result to the next agent, we run, we get the result, we pass the result to the next agent, then eventually we get the final result. So we have like researcher, writer, editor, boom, and then we get the response, okay? Then we have parallel. Parallel allows us to run these all concurrently. This means that I can run all three agents at the exact same time at scale, so I don't need to wait for one response before I get the next. Then we have router. As you can see, we can route between different ones. We have swarm, handoffs between different agents. We have round robin, random, and manual, a bunch of different strategies that you can use here when you make these agents. Now you'll notice that there's a special syntax. It looks like this. These kind of two, I don't know what you call them, greater than signs. And this is the same syntax as writing this. This just means run these agents sequentially. You're kind of piping the response into one another. Or alternatively, you can define an agent and you can just specify the strategy as you see here. Okay, and then you can just run the pipeline like this and get the result. So I'm going to show you a few different strategies here so you can see the time difference in the response that we get. But notice that if I want to run them in parallel, same thing. I define three agents, strategy parallel, boom, we get the response. Then if you want to get the sub result, you can have a look at it here. Handoff, the default one, you just pass them in here. Strategy is handoff. It will go and handoff as needed. Router, you can set up agents. You can also set up a router. For the router, you can actually use an agent to do this. You have a classifier agent. It says classify the request and then just reply with the correct category, and then it will call the correct one. Okay, and then swarm, and you can go through and you can view how all of these work, but I'm going to show you the code example right now. Okay, so let's go through the code that I have right here. Okay, so first things first, we just bring in the imports, we disable some of the logging, kind of errors and warnings you're seeing. We specify the modes that we want to be able to run, so sequential, parallel, nested, and worker. We then have some various tools here. Now notice that these tools use something called credentials. Now when I specify a credential here, this effectively means that we need to grab this credential from our server in order to use it inside of this function. So I say credentials is equal to firecrawl API key. Now what I'm doing is saying API key is equal to os.environ firecrawl API key, and this will automatically set the firecrawl API key that's going to be stored on our server, which I'm going to show you how to do in a second, in the local shell while we're running this worker. So this means any credentials that you want to have, you can store them directly on the Agentspan server, which again, we're going to look at in a minute. You can grab them when a tool is called and then use them locally without having to expose them locally permanently. So only when they're needed, they can get pulled down. So essentially, I'm going to use Firecrawl. If you want to sign up, you can get a free account. You don't need to pay for it. You get a bunch of free credits, and this will allow you to do a ton of scraping and searching of the web more effectively than with like a default search. So I'm using Firecrawl to just search the web for a bunch of pages on whatever topic we're going to look up. I then have this fetch page tool. This can get an individual tool and actually grab all of the content from the page and give us the information so that we can scrape the content. Okay, so just two tools. Now I have a researcher agent. This agent, I give it access to these two tools, search web and fetch page, right? And that's it. Then for the writer agent, I just give it some different instructions. I don't even change the model. For the editor, same thing. I just give it some different instructions. For the market analyst, give it different instructions. And I just have all these different agents that I've created. I then create an analysis team. And this analysis team I want to run in parallel, where I say, hey, for the market analyst, the risk analyst, and the financial analyst, so these three right here, we want to run those at the exact same time. So I just specify that I'm going to run them in parallel. I then create these pipelines. So I have a publish pipeline, which is my researcher, writer, and editor. So let's have a look here. We do the research, we do the writing, and we do the editing. Now, when I do that, because of the syntax that I've used here, I'm running them sequentially, which means I need to wait for the researcher to go, then the writer to go, then the editor to go. Then for my nested pipeline, this is where I take my analysis team, which I run in parallel. And then after that, so after I get my analysis, I write the researcher, writer, and editor. So I run this whole thing sequentially, but this first step runs these three agents in parallel. So I've created this kind of like multi-agent, orchestration where my analysis team goes in parallel first. Once the analysis team is done, then we go sequentially to the other agents. Hopefully that makes sense, but that's kind of how I've set up these agents to call each other. And notice we just have two simple tools, but we could use anything from agent 2 or agent 1 with the agents that we have in this example. Okay, now I just have a few functions, one to render the output, one to slugify something, one to save the report. These are just functions that I'm manually calling, and we're just going to save a report in a folder called reports directory. And that folder is just going to look like this, path reports. Okay, so that's it. We're just going to save like a markdown report with the information that we get from these agents. Now you'll notice that I just have this run pipeline function. This allows me to take in either sequential, parallel, or nested. You can see if it's sequential, we run the publish pipeline, which is this. If it is parallel, we run the analysis team, which is just the analysis. And if it is, let's go back. What's the other option we had here? Nested, then it runs my nested pipeline. Then what we do is we just say with the agent runtime, hey, we're going to run whatever pipeline mode we have. That's like this. So just which one are we going to execute? This is the topic that we want to research. And then we just have some runtime. We get the execution ID, we get the status, we get a path to the report, and then we just save the report. And that's it. Okay. Then serving the worker, don't worry too much about this. And prompt mode, this just allows me to essentially type directly into here and specify, hey, what do I want? So we can run it. So let me run it and show you what this looks like so you get a sense of how this functions. So I'm going to say uv run agents / and then this is going to be agent3.py. Okay, for the mode we're going to pick. So for now, let's go with parallel. Topic, let's go with tech with Tim. Okay, so for parallel, what this is going to do, again, let's just look at the setup here, is it's going to run the analysis team, which just does market analyst, risk analyst, and financial analyst. Now, this probably doesn't make sense for me because tech with Tim is not really something that's going to have like a market analysis. But if we want to see this running, we can go here, we can save, and you can see that this is running. We actually have 3 agents running. And if we go back to the main execution, see we have analysis team, financial, risk, and market. And then if we go back here, it says the report was saved to this directory. And if we open up the report, we get the full report from these 3 different agents. Okay, cool. Now let's try a different execution mode. So let's go uv run agent3.py, and let's try nested. For the topic, let's go NVIDIA stock. Okay, now if we go here, let's go to our agents. You can see that we now have a bunch of agents running, right? So we have the analysis team, researcher, writer, editor, the analyst team, market, risk, financial, and these are going to run sequentially. So if we go and have a look at this, the first thing we're doing is running the analysis team. The analysis team we need to run sequentially, so we're waiting for all of these to finish. Okay, looks like they're finished. Now we're going to the researcher. So the researcher is going to have the input from the analysis team, which you can see is piped in right here. We're going to wait for the researcher to finish, and then as soon as the researcher is finished, we're going to go to the writer, and then we're going to go to the editor. So this, of course, is going to take longer, but that makes sense because we need to go through this flow to pass the data between the different models. So let's just refresh here, wait for it to finish, and see what we get. And actually, if we go to the main execution, you can see that we're running this analysis team, and then this researcher, and we can just wait for the researcher to finish, and we should see it all right here. Okay, so it's running now, and you can see that we have a lot of different tool calls that are being executed here because it's using the search web call from Firecrawl. Now, if I check here, it actually says the Firecrawl API key is not defined, so I'm glad we saw that. And you can see this is just going to continue to keep retrying and retrying until I eventually crash this, or I provide the Firecrawl API key, which is kind of how this is designed to run. So what I'm going to do is just quit out of this for right now and show you how we can provide that key. Okay, so like I mentioned before, you can actually store credentials on the server, which we need to do because of how we're looking them up in the tool. And the way to do that is the following. You're going to type uv run, if you're using uv, agentspan credentials, make sure we spell that correctly, and then set, and then you're just going to set the credential that you want. Now in our case, it is the firecrawl underscore API underscore key, and I'm just going to make this equal to my firecrawl API key, which I will disable afterwards. Okay, so we're saying UV run agentspan credentials set firecrawl API key, and we need to remove the equal sign because that's how the syntax is, and now we've stored this on the server. So now we may need to restart the server, I'm not sure. Let's actually just go here and check. We can refresh, and let's go to credentials. And okay, it looks like the credential is now here, so that's good, so it's stored. And what we can do is rerun our agent, okay? We're gonna run this in the, what mode was I running this in? The nested mode, I think? Yeah, so let's run this in the nested mode, and let's look up NVIDIA stock. Okay, and hopefully this time it will work once we get to the step where it's trying to call firecrawl. Okay, so I just opened up the server and we can see the researcher is running now. This is the one that takes the longest because it's using firecrawl, but you can see that it's fetching all of these different pages, right, to get all this information about NVIDIA. You can see if we go back to the top, I believe it used, yeah, search web. So it was searching, past the input query, NVIDIA investor relations, annual report, and then it got all this output, and then it went to search all of these individual pages, and we can see the full flow right here until eventually we get the output. And if we go back to the agents, we can see now we're just at the writer, which is going, and then we should be good. So let's see what response we get. Okay, boom, and it looks like we got the response. And if we go to the reports here, we can open this up. Let's just preview it here. And we can see our full markdown report about NVIDIA stock analysis with the different sources. Let's just click one and see if it works. And boom, yeah, we get like the full report. I guess it's long. I'm not gonna wait for that PDF download and all of the other information. Okay, so very good. The nested agent is working. So that's pretty much what I wanted to show you for Agent 3. Now what I want to do is move on to a few other parts that we should be understanding, which is testing and then the durability features. So how do you actually resume an AI agent when it crashes in the middle or it's waiting for a human or something along those lines? Let me show you. So what I've just done here is written a short file that shows some basic usage of testing an Agentspan agent. Now, what we're able to do is we can test these agents without actually having to make an LLM API call to ensure that things like the model or the Pydantic response model they're using or the tools that they're using or these kind of things work properly. So for example, what I've done is I've said, hey, I want to test agent 2. So I brought in some stuff from Agentspan. I've brought in the support response and the support agent. I have an example refund policy where there's like some thing that we should be getting as a response here. And what I've said is, okay, hey, we're going to do tool call. The tool call is going to be searching the knowledge base. We're going to have a query, which is the refund policy. We're going to mock the tool result, which will be refund policy. And then we're going to mock done, and we expect that we should get this support response. So we're mocking a lot of the functionality, but again, it's still good just to make sure the agent's working as we expect and to run extremely quickly without relying on LLMs. We then can use a standard expect, so we expect the result to be completed, the output to contain refund, and we expect it to have used this tool, search knowledge base, right? If we give the support agent this, which is what is the refund policy. So we mock all of the events, but we can just make sure that those events are triggered properly. Now there's full docs on how this works. I'm not going to go through all of it, but very basic. If we want to run this, I can just come here and go. Okay, so sorry, I just moved some of the import stuff around because I had it in the wrong place. But anyways, if I go here and I run this now, you can see mock test passed and all is good. We didn't get any errors. And then if we change this to maybe say like, dot refunded instead of refund, and we run this, you can see that we get an assertion error and it says, hey, there's some issue, you need to now go and fix this. Okay, so just showing you the basic testing usage. Okay, so now I want to have a look at the durability feature here of Agentspan. And what I mean by that is if an agent were to crash or go offline, we can restart it without having to repeat all of the steps. So let's imagine we have a simple agent like we have here, where there's a slow step, tool that runs. It takes 3 seconds to run. Notice also I added a timeout. You can do that on various tools. And what I've done is I've told the agent, hey, I just want you to run a 10-step workflow by calling the slow step for each step and run it 10 times. That's it. So this will take 30 seconds to run. But we might make it to step 9 and something might crash or break, and then we would have to restart from the beginning if we didn't have this durability. So what I've done is I've set this up so that we have a mode. We have a start mode. We also have a resume mode. Now you would have this if you're running this in production because you would know the execution ID when these agents are running, which I'm going to show you in a second. So anyways, you can see that if the mode is start, what I'm going to do is I'm just going to start the 10-step workflow, right? And then I'm just going to stream the handle. And this is just going to print out everything that's going on so we can see until it says that this is done. That's it. Now, if the mode is resume, I'm actually going to serve the durable agent. Okay, so I'm going to start the agent. And then what I'm going to do is connect to the execution ID that we had previously. So this is going to allow me to connect to the existing execution. And because this agent will be running, we can just go and resume from where we left off. So I'm just serving the agent. So, okay, start the agent. And for our handle, rather than starting a new process, just connect to the previous one that we had. So any of these execution IDs that are not yet finished. Of course, there's a lot more scientific way to go about doing this, but that's the basic way that I'm going to show you. So let me show you what I mean. Let's open this up and let's go UV run. And let's spell this correctly. And then agents/crash resume demo. Okay, so let's let this run for a second and let's wait till it gets to kind of some, later steps. So let's go back here to our agents and you can see the durable demo is running. It's running the slow step. And if we keep refreshing here, we should just see that it keeps moving on to the next step. So now we're on step 2 and it's just going to keep going, right? And it's going to do this, well, up to 10 times. So let's wait. Okay, refresh again. You can see now we're on step 3. And then what happens if I just crash it? Boom, it stops. Well, if we go here, you'll notice that this is still running, right? So we made it to step 4, but the slow step, we're just waiting on this to finish. So what can I do so that I don't need to restart this from the very beginning? And you'll notice it's not going to advance any further, right? We're still on step 4 without having to restart the whole thing. So if we go here, you'll see that we have an execution ID that would have been printed out. Looks just like this. So we're just going to copy that execution ID and we're going to paste that right here. I'm just going to remove the spaces. I'm going to change the mode to just say resume. So now what's going to happen is I'm just going to go and I'm going to use this where I'm going to connect to that previous execution ID. Now, because all of the state is stored here on the Agentspan server, when I reconnect, so if I just restart this here, you'll see that it brings me back to where I already was and I have all of the state already there and we can now just continue. And if we refresh, you'll see that we now go to turn number 5. So I didn't restart anything, I didn't lose any state, I didn't lose any information. I just go from where I left off and I just restarted the worker. So this is the important thing to understand is that Agentspan is storing the state, right, and kind of all of the information, and your worker is just executing the code, right? It's executing the functions, it's completing the task, but you, at any point if it fails, can go back and reconnect to that. So imagine you're writing a platform, you just store all your execution IDs. If any of them fail, you just simply reconnect back to them and continue when the worker comes back online, because that's something that happens a lot in production. And same thing, can I quit maybe in time? I'm not sure if I was able to quit it in time or if this is going to be completed now. Let's go down here and see. Yeah, so it's still waiting on the LLM call. So now same thing, if I run it again, boom, you see we get right back into the execution we had before and we're done and all of it's finished and we get whatever that final response was, which if we look here, this 10-step workflow is complete. Steps 1 through 10 will run in order. Boom. Okay, so that's what I wanted to show you with this kind of crash and resume and how easy it is to get back into the state where you were before. Now, lastly, let's talk a little bit about deployment and then we're going to be done with this course. Okay, so now let's talk a little bit about deployment. Now, I'm not going to deploy a full application here, but I just want to discuss how you can move to this stage if you do want to deploy your apps. Now, if you just want to use local development like we were doing, right, you just run the Agentspan server and that's it. It will just store it in a local SQLite database. However, if you want to go to a deployed environment, you probably want to use PostgreSQL and some kind of Docker Compose to be running this for you. Now, in order to do that, you can just pull the GitHub repo that Agentspan has. I'll leave a link to it in the description. And when you pull this, it gives you the information here. You can go into the deployment and then Docker Compose directory. So if you go here, they have deployment, right? And then they have Docker Compose. And from Docker Compose, you can just adjust the variables here inside of the env.example. So you can put any environment variables or like API keys that you want to have. You can put the, Postgres database that you want to connect to, so that rather than running it locally, it's going to run with that remote DB, so you can also connect to it as needed. Now, it also goes over exactly how to deploy it using Docker Compose. This will just deploy this server for you. Now, as soon as this server is deployed, all you need to do is just point your workers to this server. So as it says right here, all you have to do is just say, hey, here's the URL where this is running. It could be running on this server, it could be running another server behind some endpoint or behind some URL, whatever. And that's it. Then you just point it there with the Agentspan server URL, you start working and everything is good, right? And this can be scaled as much as you want. Now, there's a bunch of other options in terms of using Kubernetes and setting up the auth and all of this kind of stuff, which I'm not going to go through here, but you can see that you can set an auth key, you can set an auth secret, and then you can also just configure those directly from code. So now if someone wants to connect to it, they do need to pass those values from their worker. So you have some kind of secure authentication going between, well, the worker and between your Agentspan server. And that's pretty much it. That's all you need to do for deployment. Okay, you also can obviously self-host this, as it says right here, and it kind of explains how you have multiple workers going to the server, connected to Postgres, and you can see all of the different options, but it's very straightforward. It's just a matter of essentially deploying the server, and then once the server is deployed, pointing your workers towards, and then adding that basic auth kind of protocol so that not anyone can connect to the worker. So that's it, guys. That's gonna wrap up this video. That's pretty much all of the core things that you can do inside of Agentspan. Of course, there's a lot more. I didn't go over everything, but this should give you a really good head start to building production-grade AI agents in Python. If you enjoy this type of video, make sure to leave a like, subscribe to the channel, and I will see you in the next one.